This was a pop quiz one, which was related to the Newton's law of motion. So in the first question, what is meant by Newton's first law? So how we define the first law? The first law is also known as a law of inertia, that an object is at rest, it remains at rest, or object is moving at a constant speed. An object is moving at a constant speed. It will continue to move, and the resultant force is when there's no resultant force. If an object is at rest, it remains at rest. If it's a moving object, it will continue to move until there's no resultant force act on it. Newton's third law identify pair forces for say two ways by which the pair forces are identical. What are the similarities of the Newton pair forces? And then what are the differences of the Newton pair forces? The similarities, how they're same, like they should be same type of the force. If one is gravitational, the other should also be gravitational. If one is a contact force, the other should also be a contact force, or electrostatic, other should also be electrostatic. They should be same type. They should act in the same line, acting in, they will have the same magnitude as well, acting in the same time. So same magnitude and acting in same time, same line, same type, you can refer. How these Newton pair forces are different from each other. They're acting into like opposite directions, different directions, and they're acting on different objects as well. Like when we say a Newton pair force, an object is on the table. So what are the Newton pair forces? The weight of an object is acting down, and like the downward force is there, and a normal contact force from the table is upward. So they are acting in opposite directions. So the directions are opposite. And the other difference is uh, acting on different objects or two different objects. One of the force acting on a car can be described as follows. The earth exert a downward gravitational force of 12,000 Newton. Describe a pair force. So example, the car is, the gravitational force is due to, like, the earth is pulling the object with a force of 12,000. So object will also, the pair force will be the force of the object on the earth. Say this is a car and it experiences a gravitational force of 12,000 Newton. So if this car experiences a 12,000 Newton gravitational force, so what will be the pair force? The pair force will be 12,000 Newton, the force of the car on the earth to pull the earth, that is a gravitational force, which will act in opposite direction. So the Newton pair force will be a 12,000 Newton force on earth by the car. The next question, opposite poles of the magnet attract one another. Using this principle, a student tries to design a car, and that could be a self-propelled using a magnetic force. His design is shown below. A magnet A, this is a magnet A and a magnet B. A magnet A is attached to a body of a toy car, and a magnet B is suspended from the driver hands by a rigid rod. The magnet A is identical to magnet B. The student stated that as long as the opposite poles of the magnets are facing one another, the attractive force created should cause a toy car to move. Explain why in practice this could never work. So why it will not work? First thing, when we talk about the Newton pair forces, so this magnet B is pulling magnet A is pulling magnet B. Say this was 10 Newton, this will also be 10 Newton. But this magnet B, a person is holding this magnet B. So as a result, what will happen? This whole person or along with the car will experience a backward force of 10 Newton. And this 10 Newton, because the idea is that whenever we talk about Newton pair forces, we should consider that this is north south, this one is south and north. So if this is pulling by a force of 10 Newton, this also pull by a force of 10 Newton. Now, the magnet B is connected with a person and then a person is there inside a car. So this whole object will experience a backward force of 10 Newton. So for this backward force of a 10 Newton and the forward force of 10 Newton, what will the resulting force on the car? The resulting force of the car will be 0 Newton. So the car will never accelerate or it will not change its state. So the points how you will mention according to Newton pair forces, the action and reaction forces will be equal and opposite in direction. So the force experienced by magnet A will be equals to force experienced by magnet B, but they are in opposite direction. But because what happened, the magnet B is like a person is holding a magnet B. So the whole 10 Newton force is not only experienced by magnet B, it is experienced by a person as well as a car. In the car, is there. And that force cancel out with a forward force of a magnet A. So as a result, there is no resultant force acting on the car. As there is no resultant force acting on the car will not change its direction or its motion, or it will remain at rest. Is it clear? Question two. This will work if the question, this will work if, for example, if we were having two separate cars were there and both were having the magnets. Like this was not connected. And there was another car here. In this case, it will work. So if an engine is driving this car A, or example, a car B with attached with a magnet B, in that case, as this car B is moving forward, there will be attraction. And in this case, this forward attraction create a resultant force because there is no backward force here or friction will be there. But if we neglect the friction, so there will be a forward force on car A and this car A will also accelerate as the car B is accelerating. But because they are connected by a same line, so in this case, the car A and B does not, like magnet A and B, magnet B cannot cause an acceleration to a car which is attached to magnet A. Any doubt in this? In question 3, a student entering a physics classroom sees the following sentence on the board, and these sentences are being used as an examples in explanation of Newton's third law. A car tire exert a frictional contact force of 300 Newton backward. The force exert the frictional contact force 300 Newton forward on the tire. State Newton third law and how these sentences provide a good example of a Newton third law pairs. It's of 5 marks. So again, you have to write the answer, and whenever like high weightage is there, it should be clear. Like you have to relate the sentences with each other. So first thing, what is the Newton pair, Newton third law, which state action and reaction forces are equal but opposite in direction. And how this provide a best example of a Newton pair force, as you can see, car exert a friction force on the road, and the road exert a friction force on the car. So they are acting in two different objects. And another example, acting in opposite direction. One is a backward, another one is a forward. Another one that a 300 Newton is there, so same magnitude. Another one, they are same type of the force. So how you list this? First thing, you will list Newton third law, that action and reaction forces are equal and opposite in direction, and acting on two different objects, like car exert force on the road and the road exert force on the car. That is one difference. Another one is a backward, another one is a forward. Another relation, one is 3 Newton, the other is also 3 Newton. And another similarity is there, frictional contact force, friction contact force. So this is how you list them. So state the Newton third law and just list these points, like mentioning car exert force on the road, as a result road exert force on the car. The force of the car is backward, the car exert a backward force on the road, so road exert forward force on the car, opposite direction. They are in same magnitude and they are same type, as both are frictional contact forces. In question 4, a student has two magnets A and B. Magnet A is smaller and weaker than magnet B. The magnet A is determined using a digital, the weight of a magnet A is determined by a digital spring balance, and magnet B by using a top pen balance. When magnet A is moved to a position just above the magnet B, there is an attractive force, and the reading on the two balances changes. How the reading on the balances changes? So first thing, we will list, like their opposite poles are facing each other, so there will be attraction, action and reaction forces are equal but opposite in directions. So a magnet A will experience a force from magnet B downward, and a magnet B will experience a force from magnet A upward. They are same magnitude but opposite in direction. So what will happen to the reading on the balance, the top pen balance? Because the weight of a magnet B is downward and the Newton pair force for a magnet B is upward. So as a result, what will happen? Reading on this balance will decrease. And same way for the digital spring balance, the weight of a magnet is already acting downward and there is a Newton pair force that is also acting downward for magnet A. So as a result, greater downward force. So greater downward force means the reading on the digital spring balance will increase. So this reading will increase and the reading on the top pen balance will decrease. And the increase in the reading of a digital spring balance will be equals to decrease in the reading of the top pen balance. So listing the Newton pair force, then one mentioning their directions, and then resultant force for the top pen balance, the resultant force decreases, and for a spring balance, resultant force increase. Is it clear? Question 4.